Hi, welcome to Mr. Slaney's YouTube math channel. Today I'm going to focus on using the initial condition to find the particular solution for a differential equation, which is a very fancy way of saying I'm going to solve for y, and then I'm going to use this information to solve for what exactly c is. This lesson is assuming that you're already proficient or recognize how to use separation of variables. So I'm going to first solve this guy. I'm going to do one easier problem, and I'm going to do it two ways. And then I'm going to show you a more difficult one. So in total, you're getting 3 reps watching this video. Separation of variables. Hopefully this is straightforward. Multiply each side by y, multiply each side by dx. You end up with this guy. Again, this video is assuming that you already know how to do some of this. I'm going to integrate. There's a 1 exponent on each of these. So I'm using the anti-power rule. And then I have the c. Now there's 2 schools of thought in actually figuring out what c is. School of thought number 1 is I'm going to use my initial condition now. And this just says if x equals 3, y equals 4. You're going to have some x and some y. Although you might have t, you might have h, you might have q or whatever. You've got a dependent variable and independent variable, usually x and y. Like I said, right now this is the easy version, but I'm going to plug these in right now. 4 squared over 2 equals negative 3 squared over 2 plus c. This c is now locked in. 16 over 2 equals negative 9 over 2 plus c. Add 9 over 2, add 9 over 2. 25 over 2 equals c. We are still in method 1. I'm going to plug this now back into my original equation, and then I'm going to solve for y. Negative x squared over 2 plus 25 over 2. And now I'm just back in the same spot. This c is now set in stone. I'm going to multiply each side by 2. This distributes and cancels out. Y squared equals negative x squared plus 25. Square root to cancel that out. Have to do the plus or minus. Y equals plus or minus the square root of negative x squared plus 25. Please note my y is positive, so I am just going to have the positive square root of negative x squared plus 25. Like I said, I didn't want to get bogged down in too complicated of a problem. The thing to pay attention to is that I took these values that were given in the problem and I plugged them in right away to figure out what c is. Then I just solve for y. That's it. Let's look at it the slightly different way. That if I solve for y first, right? Y squared over 2 equals negative x squared over 2 plus c. Let's solve for y. I'm going to multiply each side by 2. And this is where things get a little weird. Because 2 times c is still c. I don't need to adjust that c at all. Y equals plus or minus the square root of negative x squared plus c. This c is on the inside of the squaring, right? Or excuse me, of the square rooting. 1/2 power. 1/2 power. And now once I'm here, I'm going to use, well, if x equals 3, y equals 4. Watch, 4 equals plus or minus the square root of negative 3 squared plus c. Let's see, this has obviously got to be positive because this number is positive. Let's just clean this up a little. 4 equals the square root of negative 9 plus c. Let's square each side. 16 equals negative 9 plus c. Add 9, add 9. 25 equals c. All right. So I did this problem 2 ways. The first time that I did it, I solved for c right away, and then I just plugged that back in to my where I was. The second time I did this, I solved for y and then c. But notice, Once I plug this back in, shove it in there, y equals the positive square root of negative x squared plus 25. These are the same. Right is right. Positive only. All right. I would rewatch that in the last 45 seconds or so. I just re-outlined. Solve for C first, solve for C later. Use that initial condition. Let's do a harder problem. I'm going to make a note. Starting this around the 5:30 mark. Here is a harder problem. This is actually pulled directly from the 2023 or 24 AP exam. Here's my initial condition. Here I've got h and t. After I use separation of variables here, I get 1 over h minus 1 dh equals 1/2 cosine of t over 2 dt. And again, that's by looking at this, dividing by h minus t, and multiplying by dt on each side. There are 1,000 videos on this problem. I actually will. Do I have it easily here? No. Let's integrate. Let's see here, u equals h minus t du d capital H equals 1, du equals d capital H. This is 1 over u du, or natural log of u, or natural log of h minus 1. You don't need to do all that. I'm being a little bit extra. Here, I'm going to do u equals t minus t over 2, du dt equals 1 over 2, du equals 1/2 dt. Oh my god, I can swap that out. Didn't think you'd get to see such a nice even thing. Cosine of u, du, sine of u, I'm going to put the plus c on this side, sine of t over 2 plus c. So I've done all the integrating. I have my c. I'm just going to pull out a new piece of paper to wrap this problem up. Natural log of h minus 1. And what's my initial condition? My initial condition is h of 0 equals 4. I'm going to solve for c first. So my output is 4, my input is 0. Natural log of 4 minus 1 equals sine of 0 over 2 plus c. Natural log of 3 equals sine of 0. Sine of 0 is 0 plus c. Natural log of 3 equals c. Let's plug that back in. Natural log of h minus 1 equals sine of t over 2 plus natural log of 3. Whoa! Logarithms are tricky. I'm going fast. Remember, my base of my logarithm is e. I'm trying to get h out. If I transform this into exponential form, I get h minus 1 equals sine e to the power of sine of t over 2 plus natural log of 3. And then I just add 1 to each side. H equals e to the power of sine of t over 2 plus natural log of 3 plus 1. Notice that the plus 1 is not part of the exponent. All right. Let me actually just look something up really quick. Yes, this is from the 2024 AP exam. This is my attempt on this problem. There are a lot of videos on how to do this particular problem. You would want to Google 2024 question 3 AP Calc AB or something like that. I would focus on rewatching the first 5.5 minutes of this video though. I hope you're having a good day. I will talk to you soon.